welcome everyone. My name is Mike Kelly. Today we'll be going over Navlog start to finish. Hope you like it, buckle up, and if you have any questions, please feel free to ask at any time. All right, hello everyone. So what we're going to be doing today is we are going to be going over Navlogs, and what we're going to start out with is we're going to go to ForeFlight. So we'll go on ForeFlight here. And what we're going to be doing when we're on ForeFlight is our route today is going to be from where? We're going to be going from Stillwater right down here, all the way up to Salina. All right. So now they're going to Salina. I'm going to write in on the top of your right-hand screen here. We're going to be going from Stillwater all the way down to Salina, so I'm going to write those things in. And then I'm also going to write some other things in. Top of climb. So that's going to allow me to show the pilot or whoever's flying, how much fuel I'm going to be using during my climb, how long it's going to take me to climb, and the distance. Same thing for our descent. All right. Secondly, I need to pick out some checkpoints or some fixes along my route. And what this allows me to do is, as I'm flying along my route, it allows me to look outside and visually see if I'm on course, off course, and then so on and so forth. All right. So what you're going to do here is I'm going to come up here. I'm looking at Perry Municipal Airport, and I can see that there's also a highway here. So I'm going to write F22 for Perry and the highway. So I'm using two very prominent things on the ground that I'm going to see. I'm definitely going to see the highway, and I'm going to be able to see Perry Airport. So I'm going to use those things, and then I can cross-reference and be like, okay, I'm on a highway, and we look to my left, and then I see Perry, and then I know that I'm on course. So on and so forth with picking prominent things like Ponca City. I have Blackwell Airport to your left, and then Ponca to your right, and it's a very populated area, and then some tank farms and a powerhouse, which are very prominent things over there in Ponca. Let's move up. I could see that I picked out Wellington with a highway. I picked out Wichita. I then picked out 47 Kilo. And then I also then picked Salina. So 47 Kilo TOD, top of descent. And then we're going to find Salina. So generally, when you guys are doing this, please pick points that are generally about 20 nautical miles away from each other. All right. And then just for today, I picked points that are a little longer from each other. All right. Second thing that I need to do is I also want to note that you can either use ForeFlight or SkyVector. A lot of people love SkyVector. A lot of people like ForeFlight. It doesn't really matter. However, when you are doing this today, there are some things that you need to pay attention to. What ForeFlight gives you based on your track. Is it magnetic? Is it true? And then how we interpret that. So looking here, I see a 168 magnetic course going south and 348 going north. Let me redo this real quick. All right, my course is about a 347. However, we need to pay attention that this is actually magnetic. The chart that we're going for in our Navlog today says that we need true course. All right. So how do we get true course? Well, we're going to be looking at some lines on our VFR chart here, and they're lines that connect equal areas of magnetic variation. So all along in the United States and in the world, there are lines that connect equal areas of magnetic variation. Now you can notice how this one is slightly slanted, this one is straight. They don't always go perfectly straight, but they follow the variation along where you're going. On our route today, the 3-degree east line of magnetic variation, you can see 3 degrees east variation is right bang smack in the middle of our route. So we'll just use that along the entire course. We have a saying called west is best, east is least. So you can see east is least, west is best with a minus and then plus sign, and then your variation accordingly. So you'll write a -3 there. And then now, how did I get my true course? Well, to go from magnetic to true, we do the opposite of our saying, west is best, east is least. So instead of subtracting east, I add east. So let's look over here. We'll walk through this together. We want it true course. This is the next step after we do this, our true course. So is 340. Let's look at our four-flight chart. 347 magnetic on our four-flight chart. And we want to get to true course. Not east is least, but east is now going to be best. So we're going to add 30 degrees to 347 to give us 350 true. So we're going to put 350 in our true course section. Then you're going to use your -3 for the variation. And then now that we're saying that rule will apply in this scenario. So four-flight gives you magnetic if you use sky vector. And let's click on the nav log over here. You can notice on the left-hand side of your screen, 350 true, 347 magnetic. So just like four-flight, but however, they give it in, they present it differently. All right. Next thing we want to do is altitude. When looking for altitude, we want to look at a couple things, and let's look at that together. And we want to look at some winds just to pick something. Pick the best winds that we're going to have. Let's look. So 241, 242, 244, 248. Now we're going to just imagine these winds. So it looks like it's going to be around a left crosswind here. Left crosswind, let's use 65 to 6,500. Actually, let's go 4,500. Winds are slightly better. Not really a big difference. You use 45 or 65. But we also want to think, we might want to avoid the Wichita Charlie airspace. So let's just use 6,500 for today. And for the first part of our course, we'll use, for the first 1/2 of our course, we'll use 255 at 28 knots, 255 degrees, 28 knots, and 5 degrees Celsius. I don't know if you can see that. Let me move it over. There you go. All right. So 6,500. For the first part of our course, we'll use 6,500, 255, about 28 knots. And then moving on for part two of our course at 6,500. Let's see. You could take an average. I'm going to ballpark this, eyeball it just for today. And what you really want to do is interpolate for all these things. So let's use 6,500, and we'll call it 266 at 21 knots. 21 knots. And 8 degrees Celsius. All right. There we go. And then additionally, we want to get weather. Current weather. Let's look at Stillwater. Stillwater weather. 180 at 7 knots. 180 at 7 knots. 10 such miles clear. Temperature 9. Dew point -1. So we know we're at 9 degrees Celsius. Altimeter 3028. And that. And then let's also look at Salina. Salina. Around our time of arrival. 170. Let's put this in. KSLN. Writing down here. We know at Salina, looking at our weather, it's going to be 170 at 9. 170 at 9 knots. 170 at 9 knots. 10 miles clear. Temperature 4 degrees Celsius. Dew point -1. Altimeter 3015. 3015. All right. Back over here. Go back to our maps. Look at our route. We got our weather. I'm using 6,500 feet. So something neat that I'm going to do here is I just think it's really easy to see everything out. So altitude from Stillwater all the way to Salina is going to be 6,500. So what I like to do in this altitude section here is write an up arrow and then put just 65. And I know that represents it in hundreds of feet. And then now that I'm already probably going to be there after my top of climb, 65, 65. Write it all the way down. I got my weather, writing all this down. Now, here is something that we want to look at. We want to look at pattern altitude. Why? Well, when I'm descending into Salina, I want time, fuel, and distance that it's going to take me to get into the pattern altitude, and then so on and so forth. So I see that field elevation is about 1,300 feet, 1,288 feet. I'm going to round that to 1,300 feet. And then I'm going to add 1,000 feet on that. All right, usually 1,000 feet above. Check for each airport individually, but Salina is 1,000 feet above, pattern altitude. So what we're going to do is right here, we're going to write a down arrow. Let's move this over here. A down arrow. And we're descending to 2,300 feet to top of descent. Sorry, one more 65 here. And then down to 2,300 feet. All right. Let's also put in some wind directions and velocities and our temperatures in our chart. Let's start filling some things in our wind section over here. So in the top right of your screen, you can see where I'm filling this in. And then you should see me in the bottom section. Hello. Let's do that. All right. Direction at Stillwater. So when we're departing out of Stillwater, what we're going to use is we're going to use some local winds. This is because I'm just operating in the general area. Then, as I get up to altitude, so like F-22, Ponca, EGT, ICT, 47 kilo, we use our winds aloft. Then going down into Salina, we'll use those local winds again. So wind direction. So here at Stillwater, we saw 180 at 7. So the direction was 180 at 7 knots. Sorry if it's not as clear as I'm doing this. I'm trying to make it as clear as possible for you. And then I'll also put a screenshot and a link of that, hopefully in the description below, so you guys can print this out and see it. All right. 180 at 7, 9 degrees Celsius. Then as we climb up, we'll just use our winds aloft for our first half portion. 255 at 28. At 28, let's do that again. And 5 degrees Celsius, don't forget, degrees C. 28, 5 degrees Celsius. And then just looking at your chart, let's look at ForeFlight one more time, and let's see where that halfway portion is. Right by Wichita, we'll switch our winds to our other value that we got earlier. All right. So one more, 255, 28. 5 degrees, 255, 28 at 5 degrees. And then going over, we'll use our second value of winds, 266 degrees, 21 knots, 8 degrees Celsius. 266 at 21, 8 degrees Celsius. Now that we're descending into Salina, we're going to use that local weather. So that's going to be 170 at 9 knots. 9 knots with 4 degrees Celsius. All right, and there you have it. It's the first part of your navlog. We're almost done. Not really. You have a lot to go. So buckle up. Sorry. False hope. Let's look at airspeeds now. What are we going to be climbing at? What are we going to be doing here? So let's write it out. And let's look together. All right. So we're going to be pulling up. this, I'll generally tell you it's going to be around 77 knots that we're going to be doing today. However, let's look. So we'll say we'll be operating closer around 1,000 feet. So indicated 78. All right. Let's go to our calibration. So what we're doing now is we're gonna try to find true airspeed at which we're gonna be climbing at. All right. So indicated airspeed. So I chose it was 78 knots. And then we're going to go to our chart. So 78, that's indicated. And we need to go indicated to calibrated. And what we're calibrating for, like what are we calibrating for? We're calibrating for any instrumentation installation error with anything. So airspeed calibration of the normal static sources. Indicated 78 knots. I could see drilling on the higher side of the 70s into almost into the 80s. It would decrease by 1 knot. So let's look at this. So that means what we're going to do is just let's put 78 in our heads right here, and we could see 80, 79, and then you could see the error as you get faster and indicated airspeed, then to calibrate airspeed. So today, what it's going to be is it's going to be 77 knots calibrated airspeed. Now, what do we do with that calibrated airspeed? Well, I have a trick for you. Let's go online. And let's go to onlineprepware.com/TX3, and you guys are going to go and find that. And we're going to be using our flight computer here to find out what our true airspeed is. We don't know what this is going to be, our outside air temperature. Let's see. We're going to press the convert unit button to go into Celsius, and we note that it's 9 degrees Celsius. Let's put that in. All right, calibrated airspeed. What was our calibrated airspeed? Our calibrated airspeed was 77 knots. Pressure altitude. All right, what is our pressure altitude? How do we find pressure altitude? Well, to find pressure altitude, what we're going to be doing today, let's do some math here. So we're always going to do 29.92. And what is 29.92? What is that? What is that? So that's that is the altimeter setting that we use for a standard day. Standard day outside, altimeter is going to read 29.92. 29.92. All right. Minus our actual 30.28. Now, when doing this, 2992 minus that, let's get my calculator up here. So 2992 minus 30.28. Figure out what that reads. So 29.92 minus 30.28 equals negative 0.36. So that notes my difference. Now, why did I do 29.92 minus 3028? The reason why I did it like that is because if you set it up just like this, the negative or positive value of the number that is the resultant of that will tell you if you have to add or subtract this to your current field elevation altitude. So pressure altitude, we are correcting. We're trying to find our pressure altitude. So we're operating at Stillwater. The field elevation of Stillwater is 1,000 feet. Is 1,000 feet. All right, 1,000 feet at Stillwater. Now, I can't really use that because the plane it's operating. What it feels like it's operating at is that pressure altitude. And that pressure altitude is corrected for non-standard temperature and other deviation or other errors. So 0.36 times 1,000 to get that in hundreds value. So minus 360 minus 360. So if my field elevation is 1,000 feet, I'm going to subtract 360 to get 640 feet as my pressure altitude. So if I'm operating at still water, the plane is going to perform as it is at 640 feet. And there we go. True airspeed, 77.08 knots. So there's barely a difference, about 0.08 difference with that. So true airspeed, 77.08. Calibrated speed was 78. True airspeed is 77. Just keep it to the nearest knot. All right. Now that's for my climb. Now let's just do climb first. We'll come back later and we'll do the cruise stuff. All right. So the next thing that we're going to do is we're going to go into our flight computer. Now there's something important that I want to note about the flight computer. Let's see, 1 second at a time. I'll go like that. One thing that I want to note about this flight computer is that if you input something incorrect, so let's say, I go in here and say, oh no, I didn't mean to do that, but I already clicked enter. I meant 625 feet. You have to restart in everything that you're doing so that doesn't mix up or miscalculate anything, right? So I want to note there's 3 sections that you need in this calculator, and those 3 sections are, say right now, wind correction, number 1, number 2, climate descent, and number 3, fuel. I like to use fuel. You can use other sections as you please, but however, fuel gives me total volume, duration, and rate of gallons. It also gives me time, which decreases steps that I have to do in this calculator, which is nice. So we're going to do ground speed. We don't know that. True airspeed, we know that. We just calculated that. What was it? And that was 77.06 knots. Let's just put 77 in. That's what we rounded to on our nav log here. So 77. True course. What is our true course? We calculated that as well. 350. Let's put that in our flight computer. 350. True heading, we don't know yet because our true heading, let's take a look at our nav log right here and let's explain what true heading is. So true course. True course, definition of that is very simple, dry and simple. Point A to point B, no corrections, just your course over the ground, no magnetic, no wind correction, no nothing, just point A to point B. All right. Now, to get true heading, we have to use a wind correction angle. So we need to find that. So to get the wind correction angle, to go to our true heading, which is the heading that we're going to be, basically the airplane's going to be flying, is, let's look over here, wind speed, right over here, 180 at 7. Wind speed is going to be 7 knots, and the direction we just said was 180. Wind correction angle of -1. So WCA, if it's a left wind correction angle, -1, the calculator already gives us that. So we're going to write a -1 right there. -1. So 350 -1 gives me a 349 true heading. Now, I already found out my variation. So what I'm going to do with that is I'm going to subtract 3 from my true heading, 349, which gives me a 346 magnetic heading. Now, we can't really go any further because we don't know the deviation. Now, what deviation are we talking about? Here, let me zoom in if you guys can see that better. It's kind of small, but just follow along as I do this and hopefully everything works out and you guys can see it. All right. All right. So why can't I do the deviation? Well, each airplane has a magnetic compass in it. And each magnetic compass, depending on the type of instruments that it has, and it maybe has a lot of electronic instruments, versus a plane that has a lot of analog instruments. All those instruments create magnetic fields, especially the digital ones have magnets inside them. They create magnetic fields whenever they're powered on, things like that. And they disturb the magnetic compass. Now, this disturbance in the magnetic compass, what that is is it causes deviation. So I talked about magnetic variation, which is variation by the Earth's fields, magnetic fields, right? However, the deviation is caused by instruments inside the airplane. So what I would do is that I would go out, let's say we're flying a certain plane, let's say we're flying plane number 47. We'll go out to plane number 47, look at the magnetic or the compass card, and each plane should have this to be airworthy. It has to have a compass card in it. And that compass card is going to indicate if, let's say I'm flying on heading X090 to heading 120, the deviation might be -6. So what I would do, just for example for today, is I'll do -6, and that'll be 340. That means I'm going to be flying a compass heading 340. Now that's just as an example for today. Now each deviation card, compass deviation card, is going to be different for each plane that you fly in, and just depending on what I just explained on that. All right, and then so far on, you put your course for the route. Beautiful. Let's move on. So that's just an example. I'll keep it there. I'll put example over here just to note it for later so we don't get mixed up. All right, awesome job. So let's go back. Let's go over here. All right, beautiful. Wing correction. I just went on a little rant there. Wing correction. Boo, boo, boo. Oh, oh. All right, beautiful. Wing correction. We found that. Everything's in. Don't click the enter button. Don't click backspace. Keep it. Ground speed. Let's say 84 knots. We'll round up to, put 84 knots over here. 84 knots for our ground speed. Now estimated, then in flight, you're going to put actual and then determine that. We don't know how long it's going to take us to climb. Let's go into climb and descent. Distance, we don't know. This portion represents how many feet we are climbing or descending. So what I need to do is, you're going to be climbing and descending 5,500 feet for today. Now, how did I know that? So 640 feet, but let's also do this I'm flying at 6,500, right? If I'm flying at 6,500, 6,500 minus 360 feet. So I'm flying at 1,000. Whoop. And I'm doing 6,500. My plane is actually performing. I found my pressure altitude earlier of 640, a difference of 360, and I just found 6140 as my pressure altitude when I'm at altitude. So here to here, if I subtract those, 640 minus 6140 gives me 5,500 of a difference that I'm climbing. So I will climb 5,500 feet. However, the airplane is not performing as if it were climbing from 1,000 to 65, but it is performing as it is, the airplane feels like it's climbing from 640 feet to 6,140 feet due to the temperature and anything that goes into whatever the atmospheric setting, all right, altimeter setting. All right, let's continue on. So 5,500 feet, that's what I'm climbing. So let's go over here. I'm climbing 5,500 feet. Now if you didn't really know don't want to calculate it by hand, what you can do, a little trick here, is 6,140 minus 640 feet. Your enter button is this orange button here, 5,500 feet. Rate of climb and descent. Now, guys, the beginning portion of this is going to be a little slow. That's because we're doing the most calculations. However, once we get past this, we do our cruise stuff. It's going to be super, super fast, and we're going to get through this like a champ. Rate of climb and descent. Let's figure out our rate of climb and descent. Now, how do we do that? Let's go over here, and let's go to page 5 dash. All right. Do I use page 5-6, or do I use page 5-7? For today's purposes and when you guys are doing it, use page 5-7. It gives great notes, everything that you need here. The difference between 5-7 and 5-6 is very minimal. This chart is slightly more accurate. Generally, it's about only 15. It's about 15 feet per minute of a difference off of this chart. That's really it. It gives you more settings. It's more accurate to the specific temperature. However, it's a lot more calculations, but just to keep things simple, and just, this is all we need, is we'll use page S5-7. Everything's needed on this page that we need here. All right, let's do this step by step. I want you guys to note the pressure altitude column on your left, and my rate of climb over here. All right, we already calculated. Let me make sure you guys can see. Oh, there we go. And then, okay. So, all right. I want you to note pressure altitude and rate of climb in feet per minute. I already showed that when I start my climb at sea level, then I have 1,000, and then we see 6,000 and 7,000. All right, so I'm finding values that can be around or near what I calculated for my pressure altitude, 640 feet and 6,140 feet. What I'm going to do is you're going to take your rate of climb, look on your top left of the screen. I'm going to point this out, sea level, all the way over to rate of climb, 720 feet. Move down to the thousands, pressure altitude, 670. Let's do the same thing for the portion right down here, 465 at 6,000. And let's look at 7,000 for 415. So what we're going to do here, number one thing is we need to figure out how many feet per minute we are climbing, where we're starting and where we're finishing. So I'm climbing from 640 to 6,140. Now I have to find two of them because my climb rate, as you can see, is adjusting and changes as you climb. Higher altitude, air density is a lot less performance, whereas you have a denser atmosphere as you're lower, better performance. So let's do that. 720, going to 670 here. How do I find where I want to go to 640? A little trick that I like to have here is as I go from sea level to 1,000, we're going to imagine that as 100%. All right, 100%. However, from sea level to 640, that represents 64%. All right, I basically just take my decimal, move it over 1, and I find out my specific percentage that I'll be increasing or finding a difference of. Let's bring my calculator in here. Let's find a difference. What is the difference between 720 and 670? That difference will be 50. So let's do it. 720 minus 670. That's a difference of 50. All right. Now I'm trying to find 64% of that. Times 0.64 equals 32. What does that represent? 32 feet is a representation of 64% as I climb. So I'm decreasing 32 feet per minute as I increase in altitude. So I'll subtract that from 720, and I'll get 688, all right? 688. I did that, and I subtracted 32 feet per minute to get 688. moving along, let's do the same thing. 68 feet per minute. Let's move down over here. Again, what is the difference between 465 and 415? The difference is 50 feet per minute. Now, let's find out what percentage that we'll actually be climbing to. So I know that I want to cruise it at 6,500 feet. However, it's like we're actually climbing to 6,140. So I'll be finding 14% of that. So times 0.14, 7 feet. So let's do 465, my altitude from here. And it's 14% of a difference, 14%. And minus 7 feet, which is 458 feet per minute. Now, as I climb up, we're going to take the average of what I'm climbing. And so let's do that. All right, so what I'll be doing is I'll be doing 688 feet. So 688 plus 458, 688 plus 458 equals 1,146 feet per minute. Take the average. We'll divide that by 2 because we have 2 values. And I get divided by 2 equals 573 feet per minute. Now, if you're able to do that and explain that to your examiner or whatever you're doing, they're really going to love that. That is exactly how you find this and how you interpolate for something like that. Now, what do I do with that information that I just got? What I'm going to do is I'm going to go to my calculator on ASA. 13.42 nautical miles. But we'll just use that for now. Okay, so beautiful. Now let's say, okay, 13.42 nautical miles. What is our total leg distance that we're going to be flying? Is from Stillwater to our first point is 14 nautical miles. So it's going to sound really awful, but we're only going to be cruising for half a mile. However, we just have to do it. So we'll do 13.42. 13.42 minus 14 nautical miles. All right. And that's 0.58 miles of a distance that we'll be traveling. 0.58. Beautiful. Put that in. All right, guys. Now let's find out. Next thing that we're going to find out is we're going to find out how much fuel it's going to take us to climb. To find the fuel that it's going to take us to climb, what we're going to do is, how do we find a rate? How do we find that rate? So we're going to go here. Same thing, gallons used. So let's write out everything again. So let's see if you guys can see this. All right, very nice. So we're gonna do, let's put that over there, get rid of this, very nice. All right, so what you're gonna do is I know for at sea level, 0.0 gallons at 1,000 feet, 0.4 gallons, I'm operating at 640. And then at 6,000, we're operating at 2.1 gallons. And at 7,000 feet, it's going to be 2.5. 6,140. We're trying to find out. Let me make sure you guys can see all that. All right, very nice. And how did I get these numbers? You know, that 0, the 4, the 2, the 2.5. That's right out of my chart here. All right, what I'm going to do. Let's do it like that. All right, so what I'm going to do is my difference between 0.0 and 0.4 is 0.4. And I'm trying to find 64% of that. So 0.64, multiply that. That gives me 0.256 total gallons. So that's total gallons from, say if I were to theoretically climb from sea level to 640 feet, that's how many gallons total I would use. Now, same thing for over here, 2.1 to 2.5. If you don't know it, it should be 0.4. Yep, 0.4. I want to find 14% of that times 0.14, and that difference is 0.056. Now, that's on top of the 2.1, so we'll add 2.1 on top of that for 2.156. Now, I'm not actually using all that fuel because I started from 640 feet, so I don't need the fuel from here. So what I'm going to do, 2.156 minus, I'm going to do minus 0.256. Total of 1.9 gallons in the climb that I'm going to use. So we'll go over here. It's not a gallons per hour rate, but for the fuel that I'm going to use for my climb is going to be 1.9 gallons. All right. I also said earlier that my duration was 11 minutes and 37 seconds. So 11:37 seconds. Estimate time and route. Next thing, going over to, okay, also one more thing. So add 1.1 gallons of fuel for engine start, taxi, and takeoff allowances, mixture leaned. Increase time, fuel, and distance for each 10% for each 10 degrees Celsius above standard temperature. Right now, still water standard temperature would be 13 degrees Celsius. I'm technically below standard temperature there, and I'm also below standard temperature, I believe. Let's see, 6,500. Let's do 6.5 times 2, just to see 13. I'm slightly above standard temperature for the in route portion. However, we're just going to leave it like that just for now. But, however, I don't need to add any time, fuel, and distance per 10% for each 10 degrees Celsius above standard temperature because I'm technically below standard temperature. And it doesn't tell me to do anything if I'm below standard temperature because this will then be the most conservative value that I'm going to use. So keep it like that. All right, let's move on to cruise. So this one's going to be a little much, but we'll do it together. And let's see. So we know, let's put some numbers in our head. So we know that at cruise, 6,140 feet is what we're operating at, right? That's what I want to find out. I want to find my cruise, true airspeed, and I'll find my gallons per hour. What is that going to be? Now, let's also pick out an RPM. So let's look at our chart here. Let's find an RPM that we can use that has good range at, it's not on the very high end because I don't want to be operating at that max power, not the gives me a true airspeed. So I'm looking at 2250 here. And let's also look at, what's between there. So 6,000, that's the lower end. And then the higher end of that would be my 8,000 foot range here. We're going to pick the closest one. So, yeah, we'll use 2,300. We'll use 2,300 here. So 2,300, that way it matches up a little easier for us. 2,300. All right. Now, are we above standard temperature or are we below standard temperature? Let's figure that out. So I know standard temperature at sea level is 15 degrees Celsius. Its lapse rate is 2 degrees Celsius per 1,000 feet. So at this altitude, we should technically be at 2 degrees Celsius, right? So at 6,500, it should be 2 degrees Celsius. However, it's a little warmer. It is, what did we say it was at this altitude? It is 5 degrees Celsius. So because it's 5 degrees Celsius on that chart, what we're going to do is we're above standard temperature. And how many degrees were 3 degrees above standard temperature? 5 degrees Celsius, 5 minus 2, 3 degrees above standard temperature. So 3 degrees. 3 degrees above above standard temp. So what we're going to do over here, standard temperature, let's figure it out together. All right, so 2300, let's write it out. Let's do it together. Let's get this done. So 6,000. All right, 6,000 feet at 2,300 RPM. 2,300 RPM. Standard. And then we'll go and we'll look at 20 degrees above standard temp. 20 degrees above plus 2,300 standard. And let's look across. So I'm looking over here. 117, 8.6. So I'm looking in this column right here. 117, 8.6. That's all the numbers I need. 117, 8.6 gallons per hour. And then 116 at 8.1 gallons per hour. And then looking at the 8,000 range. Make sure you guys can see that. Yep, perfect. And then for that 8,000 range, that's what we're operating at. So 8,000 range at 2,300 RPMs, 116 at 8.2, and then 115 at 7.8. Remember, we have to look at the notes. Cruise fairings, let's say we don't have cruise fairings, then when we subtract 2 knots, so let's do that real quick. On our plane that we'll be using, we won't have a speed fairing. So 17, 16, 15, so 115, so 114, 114, and 113. All right, decrease speeds by 2 knots. Looked at the notes. We listened to that. We did good. Now, I always find it easier to just find the 7,000s. Find the difference. We'll be operating closer to over here, so I'll just choose 115. Find the middleman in here. 8.6 minus 8.2. Divided by 2, 0.2, 8.654. So it'll be 8.4 gallons per hour. Same thing here. It'll be 114. We'll do 8.1 minus 7.8 gives us 0.3. Divide that by 2, 0.15. Now I have 0.15, and that's of a difference between 8.1 and then 7.8. So what I'm going to do here is I'm actually going to subtract that. So minus 8.1, which then gives me a value of 7.95. Right. The reason why I did that is because now I can use my 100% kind of little trick here, and I can find out, it's 6,000, 7,000, that's 100% value. I'm trying to find, what am I operating at? 6140. What does that look like? So still 2,300. I know the values over here are the same for airspeed, so 115. Same thing over here for 114. But my gallons per hour is going to be different for both. So what I'm going to do is I'm going to do 8.6. Let's do this. All right, we'll keep that there. And all right, so what I'm going to do. So I'm going to do 8.6. Just keep this value up here. All right, so I'm going to be doing 8.6 minus 8.4. 8.4. Find the difference, 0.2. I need to find 14% of that, so times 0.14 is 0.028. Now that's from 8.6 to my altitude, so that means I'm going to be subtracting it. Minus 8.6, what do I get? Just make that positive 8.572. Let's go over here. 114. What am I looking for? I'm looking for what I'm operating at 6140. So what I'm going to do is I'm going to do 8.1 minus 7.95. 8.1 minus 7.95. Subtract that from, oh, sorry, 8.1, 7.95, difference of that, 0.15. What do I do with that? I need to find 14% of it. Why? Because from 6,000 to 6,140 feet, from the difference of 6,000 to 7,000 feet is 14%. So I do times 0.14, 0.021 is what I'm going to do. And that's, I have to subtract that from 8.1 minus 8.1 to get 8.07. I will just call it 8.08. All right, now I have these awful long numbers with a bunch of decimal places. What I'm going to do after that, I know that I'm 3 degrees above standard temperature. So let's work up here. Let's just copy my information over here. Actually, I'll just do it right here. So I need to find the middle ground between here and here. All right, let's find the middle ground we're trying to find. I am 3 degrees above. What do I do? Well, I want you to imagine you have 20 different degrees of temperature, which you do between standard and plus 20 degrees Celsius. Because we're 3 degrees Celsius, we're favoring more on the 115 knot side rather than the 114. So there's no use to me interpolating 1 knot and then finding, the points of that knot. So what I'm going to do is I'm just going to write 115. Easy interpolation, 115. Now, something you can just do is find, let's do 8.572. So what I'm doing now is I'm finding my gallons per hour. So I need to find the difference between this, 8.572 minus 8.08, 8.08 equals 0.492, almost half a gallon. Now, I have 20 degrees of temperature spread divided by 20. Now, per degree of change, this number represents my gallons per hour change per degree of temperature change. So, gallons per hour per degree at this altitude, at this RPM. What I'm going to do is I'm going to multiply by 3 because I have 3 degrees of change, which gives me this value. And what I'm going to do is I'm going to subtract that from 8.572, which gives me an answer of 8. And we'll round. We'll just call it 8.5. All that work to just find 8.5 gallons per hour. But that's how you do it. We'll make a note here. Cruise 115 knots at 8.5 gallons per hour. All right. All right. Take a break. That was long. And then you guys can come back. Pause it whenever you need to. But I'm going to keep moving on. True speed, 115 knots. You could fill that in. Let me make sure you guys can see all this. Yep, 115 knots. Now this is where it gets a lot faster. We're almost done. We're finishing up maybe another 20 minutes and we will be done. 115. Write it all the way down. 115. We will descend at our cruise to our speed here. All right. What we're gonna do, we're gonna go here. We're gonna go to our calculator. Dun dun dun. And what we're gonna do is we're gonna click on flight. We now are at altitude. We're climbing. We're getting to our destination. Let me clear the space. Click backspace. Clear it up. I don't know what ground speed I'm going to be at, but I do know my true airspeed. What did we just find? Spend all that work, all that time finding 115 knots. So 115, 150 knots. My true course. What is my true course? My true course is 350. True heading, I don't know. My wind speed, I do know. Let's look up here at my top. And my notes section all the way above. All the way above. Wind speed, 28 knots. 28 knots with a wind direction of what? Well, let's look. 2, 5, 5. Let me make sure you guys can see that. 255. Wind correction angle of minus 14 degrees. Now, let's imagine we are heading of almost north, winds coming all the way from the left to the right, from the west, of a 20 knot headwind. So 20 knot crosswind, meaning, sorry. So that we're going to be crabbing into the wind, which means we have a wind correction angle of minus 14. That means a left wind correction angle is going to be minus. So I'm going to do minus 14. Let's do 350 minus 14 is 336. 336 minus 3 gives me 33 of magnetic heading. So every 15 minutes as you reset and you correct your magnetic heading indicator to your compass, you're going to be flying on that card 333 magnetic heading. Now, then you do the deviation, so on and so forth. We can't do that right now. However, that's what you're going to do. Let's go to our flight calculator. And let's do this one more time. Wind correction. Let's put in everything. True airspeed. True airspeed in the cruise section is going to be 115. 5. True course 350. Wind speed is going to be 28 knots. Let's just verify. 28 knots at 255. 28 knots, 255. Put that in there. Beautiful. Ground speed, 114 knots. So it's basically a 90-degree left crosswind here. Ground speed, 114. All right, 114. We'll go to our flight here. Then go up, climb, descent. My distance is going to be 0.58. As I just found, I'm not climbing or descending anything. And we'll go to fuel. The reason why I'm not using ground speed and fuel is because I get more information, less clicks with using fuel. Rate, gallons per hour, I calculated was 8.5. So I'll be using 0.4. 0.04. 0.04, and it's just 15 seconds. Or we'll call it 20 seconds. Go that distance. All right, very nice. Let's go to ForeFlight one more time. Let's get our other distances. Next leg, from Perry to Ponca, it's going to be 21 nautical miles, 21. Next one's going to be 36. Next one is going to be 21, and then 33. Now we can just click along on our calculator here, and we'll get that done. Let's go to flight. Wind correction here, true airspeed 115 knots. True course is going to be the same. Wind speed and wind direction also going to be the same. Wind correction angle of minus 14. Gives me 336. Sorry, it's a little weird. 336 minus 3, which is a 333 magnetic heading. Moving over, 114 is the ground speed. It's going to be the same thing over here again. Same thing over here. Minus 3, which would be a 333 magnetic heading. Same thing with our ground speed. All right, going to flight. Climb and descent. The distance that I'm going to be going on this one is 21 miles. Put that in. I'm not climbing or descending anything, so my value will be 0. Going up to fuel. My rate, found earlier, 8.5 gallons per hour in cruise. So total volume that I'm going to use for this portion It's going to be 1.57 gallons. 1.57 gallons. And let's call it 11 minutes. And we'll just round up to the nearest 15 seconds. 11 minutes and 15 seconds. Ooh, look at me. I put the distance in the time section. 21, 36, 21, 33. Duration, 11 minutes and 15 seconds. And that's it. And we do the same thing for our next one. Ground speed, we don't know. True speed 115. True course 350. Wind speed, same thing with the same wind direction. Climb and descent. Next leg is going to be 36 nautical miles. Go up to my fuel. My rate, 8.5 gallons per hour. We'll call it 19 minutes, 2.68 gallons. 2.68 gallons. Let's call it 19 minutes. Round up to the nearest 15 seconds. Then do it again. So let's see. Wind correction. True speed. True course is going to be the same. Wind speed, wind direction, same for this next one. Go on to climb and descent. Distance, not 36 nautical miles for this one, but 21. Let me verify that real quick with ForeFlight. 14, 21, 36, 21, 33. Awesome. So 21 nautical miles for this next segment. Not climbing or descending anything. So 0. We'll go up to fuel. Find a rate of 8.5. 1.57 gallons. The reason why it's the same thing above is because I'm doing the same distance, but also speed stayed the same, true course stayed the same, everything else stayed the same. So, same values. 1.57 gallons, 11 minutes, 15 seconds. 11 minutes, 15 seconds. And then for this one, please note that your wind speed and direction slightly changes. Not a big issue. We'll just go right down here. Go to wind correction. True speed, 115. True course is going to be still stay the same. Wind speed, although looking over here is going to be 266, so 21 knots at 266. Ground speed is going to be, we'll round that to 111. Ground speed, 111. 111 there. My wind correction angle, let's look. -10. And I could do the same thing for this, also this next round. That's why I'm doing it right now. Just this will be a 340 there and a 340. 340 there as well. I know I have minus 3 degrees of magnetic variation. So -3, -3. That would be a 337, 337, 337 magnetic heading. All right, so I take true course, left wind correction angle -10 to get a true heading of 340, -3 degrees easterly variation, which gives a magnetic heading of 337. Same thing from an X point en route as well. All right. climb and descent. My distance for this one is going to be 33 nautical miles. Not climbing or descending anything. Ground speed's 111. Already put that in. Fuel. Rate is going to stay the same. 2.53 gallons. 2.53 gallons. Estimated time around 17 minutes, 51 seconds. We'll round that up to 18 minutes. Then do it again. All right. True airspeed 115. True course 350. Wind speed that stays the same as last time. Remember, minus 10 degrees wind correction angle. We already wrote that all in. Climb and descent for this one. One second. So now we can do the descent information. What we can do, okay, so why we don't do 47 kilo to the top of descent is because we don't know the specified distance. We don't know how long it's going to take us to descend. However, it's super easy to find that descent information. What we're going to do here is we're going to go back to flight. And we already have all the information we need. We're just plugging in the correct numbers and data. All right. True airspeed, we're descending at our cruise airspeed. True course is still going to be 350. Wind speed, wind direction at Salina is going to be 170 at 9 knots. Wind speed 9 knots. Wind direction is going to be 170. Gives me a wind correction angle of 0. So 350 wind correction angle of 0. Put that in there in my bottom section. Minus 3 degrees east, so 350, it stays. No change. Minus 3, which is a 347 magnetic heading. All right, we can't do this bottom portion here. Just refer to my example up above if you need to find the deviation. And then you can find all your courses and all that stuff. So, beautiful. We don't know our distance yet. Let's find that out. Ground speed was 124. Ground speed here, 124. And let's find a distance for that. Climb and descent, we don't know that. However, now we're descending from 6,500. Now, the reason why I'm using 6,500 is because I'm using I'm deciding to pattern altitude. Quentin, pause 1 second. When I'm descending, because I'm descending down to... Actually, no, never mind. I got it. Okay, so we're descending down from 6,500 feet, and we're going to pattern altitude, which is 2,300 feet. Oh. Now, again, you could have done your pressure altitude correction for this one. It's going to be the same thing when you do it. And then a very standard descent rate is 500 feet per minute when we do that. Very simple, easy. 17.36 nautical miles is how long it's going to take us. Right? 17.36 for that last portion. Distance, 17.36. All right. And then what we're going to do is we're going to go to flight, go to fuel, our rate. So our rate, what we want to do for descent is we want to take our gallons per hour. It's just general rule of thumb. Take our gallons per hour of 8.5. 8.5, divide that in half to get 4.25 is going to be our rate. 4.25 is going to be your rate for descent. So 0.6 gallons is what we're going to use in the descent. 0.6 gallons is going to take me 8 minutes and 30 seconds. All right. And now that we have a distance, for our final leg, we could find, now we know what it takes us to get to the top of descent to Salina. We can take that distance, 17.36, and we can subtract it from the total distance of that route, which will be 36 nautical miles. So minus 36 nautical miles gives me 18.64 from 47 kilo top descent. So I can now go back. Last one that we're going to do. Wind correction. All right. True speed 150 knots. True course 350. Wind speed, we're going to be using the cruise route part 2 of our winds. 21 knots. Wind direction is going to be 266. 266. Yep, verify 266. Ground speed is going to be 111. Already put that in. Flight. Let's go up to climb and descent. Our distance, what we just found out, 18.64. We're not climbing or descending anything. That value is going to stay 0. Then going up to fuel. Rate of 8.5 gallons per hour. Put that in. 1.43 gallons is what we're going to be using. 1.43. And then duration 10 minutes, 5 seconds. We'll just round that up to 10 minutes, 15 seconds. Now we're just going to add everything up. Now in our notes, it did say to add plus 1.1 gallons for taxi, all that stuff, starting the engine. So let's add everything up. 1.9 plus 0.04 plus 1.57 plus 2.68 plus 1.57 plus 2.53 plus 1.43 plus 0.6 plus 1.1 gallons. So 13.42 gallons is the total amount of fuel that you will need for today's flight. Now, other SOPs, etc., require any student cross country, anything like that, top off tanks, but also VFR fuel reserves. If I'm burning 8.5 gallons per hour, let's find out. VFR fuel reserve. So plus VFR day, 30 minutes. So 8.5 divided by 2, 4.25 for 30 minutes. So we'll do that plus 13.42. 13.42 will give us a total of 17.67. I don't know if you guys can see that. 1 second. No. So I'm adding everything up at the bottom here. 17.67 gallons total to get to this route. That's the minimum fuel that you need. Now, is it smart to do that? Probably not, but I'd probably take off the full tanks and then just go as needed. Don't want to cut it close. And then time, you can add up the time on your own. And then you can note the actual time and route that it takes. You have all your distances. Total distance of that is 160 plus 0.58 plus 21 plus 36 plus 21 plus 33 plus 18.64 plus 17.36, about 161 nautical miles. All right. And that's really how you do entire nav filled out. Use airport ATIS advisories, airport frequencies, everything like that here. VORs if you need them. Make sure I'm not missing anything. All right, and so that kind of concludes today of what we're doing. Thanks for sticking with me through that. Hope this helps. If you have any questions, reach out and I'll try to help you. Thank you so much and have a good day.